Science is often seen as the ultimate authority on reality. It explains how stars are born, how cells divide, how time bends, and how the universe began. But behind this confidence lies a rarely discussed truth. There are moments when science doesn't have answers. Moments when researchers pause, debate quietly, and admit sometimes reluctantly that something fundamental doesn't fully make sense. This video explores 7 such moments, not failures of science, but its limits. The first moment comes from dark matter. For decades, astronomers observed that galaxies rotate far faster than visible matter should allow. According to physics, these galaxies should tear themselves apart, but they don't. To explain this, scientists proposed dark matter, an invisible substance that makes up roughly 85% of all matter in the universe. Here's the problem. Dark matter has never been directly observed. No particle detector has confirmed it. No telescope has seen it. No experiment has isolated it, and yet, entire models of cosmology depend on it. Science admits this openly. Without dark matter, our understanding of gravity on cosmic scales collapses. The second moment involves consciousness. We know which brain regions activate during thoughts, emotions, and decisions. We can map neural activity with remarkable precision, but no one can explain how subjective experience emerges from physical matter. Why does electrical activity feel like something? Why is there an inner world at all? This is known as the hard problem of consciousness, and science has no accepted solution. Neuroscience explains correlations. Philosophy raises questions, but the bridge between matter and experience remains missing. The third moment appears in quantum mechanics. At microscopic scales, particles behave in ways that defy classical logic. They exist in multiple states at once, influence each other across vast distances, and seem to respond to observation itself. Quantum equations work perfectly, but no one agrees on what they mean. Is reality? Does observation create outcomes? Do multiple universes branch constantly? Science admits this. Quantum mechanics predicts reality flawlessly, but no interpretation fully explains it. The fourth moment lies in the origin of life. We understand how DNA works. We know how cells replicate. We can even synthesize genetic material. But the transition from chemistry to biology, from non-life to life, remains unexplained. How did the first self-replicating system emerge? Every proposed explanation contains gaps. Every model relies on assumptions. Life exists, but its beginning remains a mystery. The fifth moment comes from time itself. Physics treats time as a dimension, measurable, mathematical, predictable, but human experience of time tells a different story. Time speeds up. Time slows down. Time feels subjective. Even in physics, time behaves strangely. At quantum scales, time may not exist at all. Some equations work perfectly without it. Science can measure time, but it cannot fully define what time is. The sixth moment emerges in cosmic expansion. The universe is not just expanding, it's accelerating. Something is pushing galaxies apart faster and faster. Scientists call it dark energy, and once again, they don't know what it is. Dark energy makes up roughly 70% of the universe, yet its nature is entirely unknown. Science openly acknowledges this. Most of the universe is made of things we cannot directly explain. The seventh and final moment is human unpredictability. Despite advances in psychology, neuroscience, and data science, human behavior remains deeply resistant to prediction. Trends emerge. Patterns exist, but individuals surprise systems constantly. Creativity, intuition, sudden insight. These remain difficult to quantify or reproduce. Science can describe behavior, but it cannot fully capture agency. Taken together, these 7 moments reveal something profound. Science is not collapsing. It is expanding into uncertainty. And that uncertainty is not weakness. It is honesty. But it also raises an unsettling question. If science doesn't fully understand the foundations of reality, what else might we be misunderstanding? In the next part, we explore how these unanswered questions are reshaping physics, biology, technology, and even our understanding of what it means to be human. When science admits uncertainty, it doesn't mean progress has stopped. It means we've reached the edge of what we currently understand, and that edge is far more influential than most people realize. The unanswered questions we explored aren't just abstract puzzles. They actively shape how science evolves, how technology is built, and how humanity understands its place in the universe. The first consequence of scientific uncertainty is humility. For centuries, every major breakthrough created the illusion that total understanding was just around the corner. Yet the deeper we look, the more layers of complexity emerge. Dark matter and dark energy remind us that most of reality operates beyond direct observation. Consciousness reminds us that inner experience may not be fully reducible to equations. Science doesn't lose credibility when it admits this. It gains it. The second consequence is new directions of inquiry. Unanswered questions act like gravitational wells for curiosity. Entire fields emerge from them. Quantum mechanics gave birth to modern computing. Questions about time reshaped cosmology. Gaps in biology sparked synthetic life research. Uncertainty is not a dead end. It's a compass. The third consequence is technological acceleration without full understanding. Some of our most powerful tools were built before we fully understood the systems behind them. We used electricity long before we understood electromagnetism. We now use artificial intelligence without fully understanding intelligence itself. This creates a strange situation. We can manipulate reality before we comprehend it, and that raises ethical questions science alone cannot answer. The fourth consequence is the return of philosophy. When equations fail to explain meaning, purpose, or experience, philosophy quietly re-enters the conversation. Questions about consciousness, free will, and reality cannot be solved by data alone. They require interpretation. For a long time, science and philosophy drifted apart. Now, uncertainty is pulling them back together. The fifth consequence is public discomfort. People want certainty, clear answers, solid ground. But reality offers probabilities, models, and approximations. When science says we don't know, it can feel distant. Some interpret uncertainty as weakness, or worse, deception. But uncertainty is not ignorance. It's intellectual honesty. The sixth consequence is the reshaping of belief systems. When science admits its limits, it leaves space for speculation, space for belief, space for misinterpretation. Some fill that space with curiosity. Others fill it with fear. This is why scientific uncertainty is powerful and dangerous. It invites wonder, but also misuse. The seventh and final consequence is a shift in how we define truth. Truth becomes provisional, conditional, subject to revision. This doesn't mean truth doesn't exist. It means our access to it is incomplete. And that realization may be the most important scientific insight of all, because it reframes humanity's role in the universe. Not as masters of reality, not as passive observers, but as participants in an unfolding mystery. Science doesn't end with answers. It evolves with questions, and the questions that remain unsolved today are not failures. They are invitations. Invitations to think deeper, to remain curious, to resist false certainty. Because the most dangerous idea isn't that we don't understand everything. It's believing that we already do. If you want to keep exploring the edge, where science meets mystery, without easy answers, without fear, and without dogma, subscribe to because the most honest words in science aren't "we know." They're "we're still learning."